Every night of your life, the moon has shown you the same face, the same soft grey markings, never turning, never hiding the side it keeps toward us. But there is another side, a hidden half the moon never lets us see, and for almost all of history, no one knew what lay there. When we finally looked, in 1959, we found something strange, a face that did not match. Tonight we drift gently to the far side of the moon and to the quiet mystery it has been keeping. Rest a while, a like and a soft subscribe. Help others find this calm. And tell me, where are you listening from? And what time is it? There, let us begin with something you already know so well that you have stopped noticing it. The moon, tonight, is showing you the same face it has always shown. The same soft, grey shapes. The same pale and shadowed markings, arranged exactly as they were when you were a child looking up, exactly as they were when your grandparents looked up, exactly as they were 10,000 years ago when someone sat by a fire and gazed at that same gentle face in the dark. The moon does not turn away from us. It holds one face toward the earth, always, patiently, through every night of every life that has ever been lived. And that is the first quiet strangeness, the one hidden inside the most familiar sight in the sky. The moon has a side we have never been shown. Settle in for a moment before we go any further. Let your shoulders soften. Let the weight of the day begin to loosen. There is nothing here that asks anything of you tonight. We are only going to take a slow and gentle journey to a place that is both very near and almost entirely hidden, and there is all the time in the world to get there. If these quiet journeys help you rest, a soft like and a gentle subscribe help other tired travelers find this calm corner of the night. That is all. We will not mention it again. Now, let your breathing slow and come with me to the moon. The first thing to understand, and we will hold it gently, is why the moon shows us only one face. It is not because the moon does not turn. The moon does turn, slowly, on its own, but it turns in a way so perfectly matched to its path around us that the same side stays pointed our way the whole time. Picture it like this. The moon takes about a month to travel once around the Earth, and in that very same span, it turns exactly once on its own axis. One full turn for one full orbit. The two motions are locked together perfectly in step, so that as the moon swings around us, it slowly rotates by just the right amount to keep one face forever toward the Earth. It is a kind of cosmic dance where one partner always faces the other, never turning their back, gliding around in a slow and endless waltz. This locking did not happen by accident, and it did not happen all at once. Long ago, moon spun faster and showed us all of itself in turn, but the Earth's gravity reached out across that 250,000 miles and gently pulled at the moon, raising small tides in its rock. And over millions and millions of years, those tides acted like the softest of brakes, slowing the moon's spin, easing it down, until at last the spin settled into perfect step, with the orbit and stopped slowing any further. We call this tidal locking, and it is not rare. It is the natural resting place for a moon held close by a planet over enough time. Many moons in our solar system are locked this way to the worlds they circle. Our moon simply reached that quiet, settled state long ago and has held it ever since. So the face you see tonight is the face the Earth gently chose ages ago and froze in place. Sit with how long that has been true. Every human being who has ever lived, every one, has seen only this one face of the moon. The hunters of the Ice Age, the builders of the first cities, the sailors who crossed dark oceans by its light, the poets who wrote of it, the children who reached up toward it, the lovers who walked beneath it. All of them, across all of human history, saw the very same markings you see now, and not one of them, not a single soul, ever saw the other side. The far side of the moon was, for the entire span of human existence, completely and utterly hidden. It was perhaps the largest nearby thing that no one had ever seen. A whole hemisphere of a world, right there, close enough to feel familiar, and yet turned away forever, kept secret by the slow geometry of the dance. There is something tender in that thought, and something a little haunting. We knew the moon so well. We had mapped every grey patch of the face it showed us, named the dark seas and the bright highlands, watched it wax and wane through every phase, and all the while half of it remained a blank, an unknown, a hidden country just over the horizon of what we could ever see. People wondered, of course. For centuries they asked what might be on the other side. Did it match the face we knew? Was it the same gentle grey, the same soft seas? Or was it something else entirely? No one could say. There was no way to know. You cannot see around a corner that never turns toward you. And then, within living memory, in the year 1959, that changed forever. A small spacecraft sent up by the Soviet Union was given a quiet and historic task. It was called Lunar 3, a modest machine by today's standards, little more than a canister of instruments and a simple camera. It was flung out from the Earth and sent looping around the moon, swinging behind it into the region no human eye had ever beheld. And there, in the sunlight falling on the hidden hemisphere, it did something no one had ever done. It took photographs of the far side of the moon, the first images ever in all of time, of the face the moon had always kept turned away. The pictures were blurry. They were grainy and faint, sent back across space by a primitive system, developed and scanned aboard the little craft and beamed home as a ghostly signal. By the standards of the beautiful images we have today, they were almost nothing. Soft smudges of grey and white. But to the people who first saw them, they were astonishing beyond words. They were looking at something no one had ever looked at. A new face, the moon's other side, revealed at last after all the ages of human wandering. And even in those blurred and gentle images, even through the grain and the haze One thing was immediately, quietly clear. The far side did not match. The face we knew, the familiar near side, is marked by great dark patches, the soft grey, seas that form the gentle expression we all recognize. People had assumed, reasonably, that the other side would look much the same. Why would it not? It was the same moon. But the far side, in those first faint photographs, looked different. It had far fewer of the dark seas, almost none of them. Instead, it seemed paler, rougher, more crowded with the small, bright rings of craters, a busier and more rugged and more scarred kind of surface. It was as though the moon had two faces that did not belong to the same person. One smooth and dark-eyed and familiar, the other bright and pitted. And strange, nobody had expected that. There was no obvious reason the two halves of one small world should look so unlike each other. A moon, you might think, should be roughly the same all over, the way a smooth stone is the same on every side. But our moon is not. It carries a deep and genuine asymmetry, a real difference between the half it shows us and the half it hides. And that difference turned out to go far deeper than those first blurry photographs could reveal. It is not only a matter of how the two sides look. It runs down into the rock, into the thickness of the crust, into the very structure of the moon. And to this day, after decades of study, after spacecraft and orbiters and landings and even soil carried home in human hands, we still cannot say for certain why the two faces are so different. It remains, quietly, one of the genuine unsolved puzzles of the world hanging right outside your window. Let us gently clear away one small confusion first, because it is a common one, and setting it aside will make everything that follows clearer. People often call the hidden half the dark side of the moon. It is a lovely phrase, and it has a kind of poetry to it, but it is not quite true. The far side is not dark in the sense of never seeing the Sunday. It receives just as much sunlight as the side we see, only on a different schedule. When the moon shows us its bright full face, the far side is in night. And when the moon hides its face from us in the dark of the new moon, it is because the far side is then turned fully toward the sun, bathed in daylight we cannot see. So the far side has its days and its nights, just like the near side, 2 weeks of sunlight and 2 weeks of darkness, turning slowly through them as the moon goes around. It is not the dark side, it is only the hidden side, the side hidden from us here on earth. The darkness was never about sunlight. It was about our own limited view, and it is worth dwelling just a little longer on how complete that hiddenness was, because it is hard for us now to imagine. We live in an age of images. We can call up a photograph of nearly anything, anywhere, in an instant. But for all the long generations before the last one, the far side of the moon was not merely unphotographed. It was unreachable, unseeable, a true blank on the map of the nearby heavens. Astronomers could calculate that it was there. They knew the moon was a sphere, and that a sphere has another side. They could even, by watching the moon wobble very slightly as it moved, a gentle nodding and rocking that let them peek a tiny way around its edges. Over the months, glimpse thin slivers near the rim of the far side, but the great central expanse of it, the heart of the hidden face, no one had ever seen, and no one knew how to see. It was a mystery you could point to in the sky, night after night, and never solve. So people did what people always do with a mystery. They filled it with imagination. Some wondered if the far side might hold things the near side did not. Hidden wonders, secret features. In stories and idle speculation, the hidden half became a kind of blank canvas for wondering, a place just out of sight where anything might be. There was no way to confirm or deny any of it. The far side kept its silence, turning away century after century, holding whatever it held in the dark beyond our reach. And then came that small machine in 1959, and the long wandering met, at last, a real answer. Let us linger on the moment, because it deserves it. Lunar 3 swung out and around the moon on a long looping path, and as it passed behind into the region forever hidden from Earth, it pointed its small camera back at the sunlit far side and took its pictures. Then, still coasting through space, it did something quite remarkable for its day. It developed the film automatically on board in a tiny self-contained darkroom no larger than would fit in such a craft. It scanned the developed images line by line, turned them into a faint electrical signal, and waited until its long orbit carried it back toward the Earth, close enough to whisper that signal home. And, down on the ground, scientists gathered around their equipment and watched as the first ever images of the other side of the moon slowly assembled themselves out of the static. The images that emerged were rough and ghostly, soft grey shapes swimming in grain and noise, but they were real, and they were the first, and the people who saw them knew they were looking at something no human had ever beheld in all of time, because they were the first to see it. They were also given the quiet honor of naming what they found. New features on a new face. They marked the great pale plains and the scattered dark patches, the few that there were, and gave names to this newly revealed land, names that still sit on our maps of the far side today. There is something deeply moving in that, in being the first eyes ever to rest on a place, and in gently giving it names so that others could speak of it. A whole hemisphere of a familiar world, nameless since the beginning of time, given its first names within living memory. And running through all of that wonder was the quiet shock we already noticed, the thing the blurry pictures made plain at once. The far side was not a mirror of the near side. It was its own strange place. Where the near side wore its broad, dark seas, the far side was bright and crowded and rough, a different kind of country altogether. The moon, that single small companion we thought we knew so completely, turned out to be a world of two halves, two faces, two characters joined into one body, and yet startlingly unalike. The mystery was no longer whether the far side differed. The pictures had settled that The mystery was why. That is where we are going tonight. Slowly, gently, with no hurry at all, we are going to drift to the far side of the moon and explore the strange and beautiful ways it differs from the face we know, and sit with the soft mystery of why. We will look at the two faces side by side. We will go beneath the surface into the hidden shell of rock. We will visit the greatest scar the moon carries, a wound so vast it is hard to even see as a wound. We will gather the gentle theories of how this all came to be, and we will end at the present moment with the small, brave machines that have, in just the last few years, finally touched the hidden half and brought a little of it home. Before we drift onward, let us rest for a moment in the gentle wonder of the lock itself, because it is a beautiful thing in its own right. Think of the patience of it. For a very long time, far longer than there have been people, the earth and the moon turned the slow dial of the tides, the earth's pull kneading the moon's rock, the moon's spin easing down by the tiniest amount with each passing age, until the spin and the orbit fell into perfect step and the dance settled into its final form. No one arranged it. No one chose which face we would see. It simply found its resting place over the ages, the way a swinging door slowly comes to rest, the way a spinning top settles, the way everything in the long patience of the universe drifts toward its quietest configuration, and the face that happened to be turned our way when the lock completed is the face we have loved ever since, the only one we have ever known. And there is a soft symmetry hidden in it too that is worth holding as you lie there. Just as we on Earth see only one face of the moon, anyone standing on the near side of the moon would see the Earth hanging always in the same place in their sky, never rising, never setting, simply there, turning slowly through its phases, fixed above them like a great blue lamp. And anyone standing on the far side of the moon would never see the Earth at all. The Earth would be forever below their horizon, hidden exactly as the far side is hidden from us. They would live under a sky with no Earth in it, only the sun and the stars wheeling by, and the strange deep silence of a place that cannot see home. The hiddenness runs both ways. We cannot see the far side, and from the far side you could not see us. Let that image settle softly, the far side of the moon, turned away from the earth for all of time, its surface, knowing daylight and darkness, but never once knowing the sight of the blue world that made it. There is a loneliness in that, and also a deep quiet, the quiet of a place that has simply faced the other way, patiently, since the beginning. We are going to go and visit that quiet place now in our imaginations and see what it is like, but there is no need to hurry. Let your body grow a little heavier where it rests. Let the familiar face of the moon hold steady in your mind, and let us prepare to drift around behind it. But for now, simply hold the wonder of the beginning. The moon shows us one face, and always has, and always will, for as long as there are people to look up and behind. That patient, familiar face, turned away from every eye that has ever gazed at it, until, almost yesterday, there is another face entirely stranger than anyone guessed. Let us go and meet it. Breathe in slowly, breathe out slower still, and let us drift around to the side of the moon that no ancestor of yours ever saw. Let us look slowly at the two faces side by side, and let the difference between them settle into you like a quiet astonishment. Begin with the face you know, the near side, the one turned toward us tonight. Look up at the moon, or simply picture it, and you will see that it is not a plain white disk. It is patterned. There are bright regions, pale and rough, and there are darker regions, large, smooth patches of soft grey that pool across its surface. Those dark patches are what give the moon its familiar look, its gentle markings, the shapes that different peoples across the world have seen as a face, or a rabbit, or a figure carrying a bundle of sticks. Whatever your eye makes of them, those dark grey areas are the most recognizable thing about the moon. They are the features that make the moon look like the moon. We have a name for those dark patches, and it is a lovely old one. We call them Maria, which is simply the old word for seas. When the first astronomers turned their telescopes to the moon long ago, the smooth, dark plains looked to them like bodies of water, like great calm oceans on another world, and so they named them seas, the sea of tranquility, the sea of serenity, the ocean of storms. Beautiful names, full of stillness and weather for places that have neither, because of course they are not seas at all. There has never been a drop of water in them. They are dry and they are stone, but the names have stayed because they are gentle, and because there really is something sea, like in the way those dark plains lie, so smooth and so level, pooled in the low places of the moon. What are they, truly, these dark seas? They are plains of frozen lava. Long ago, in the moon's distant youth, molten rock welled up from deep inside and flooded across great stretches of the surface, pooling in the vast low basins, filling them, and then slowly cooling and hardening into the smooth dark stone we see. The Maria are old lava, floods, frozen mid-spread, vast sheets of volcanic rock laid down across the face of the moon when it was young and still warm enough within to bleed molten rock onto its surface. They are darker than the surrounding land because the lava rock is darker, richer in certain minerals, and so it drinks more of the sunlight and gives back less, leaving those great grey shadows we see from Earth. The face of the moon, the soft, familiar markings, is written in ancient frozen lava. Now, hold that picture of the near side in your mind, the bright, rough highlands, and pooled across them, those broad, dark, calm seas of frozen lava, covering a good portion of the face, nearly a third of it, giving the near side its gentle patterned look. Hold it gently. And now let us drift around to the other side, to the far side, and see what we find. And here is the quiet shock. The far side has almost no seas at all. Let that sink in slowly, because it is genuinely strange. The near side is nearly 1/3. covered by those dark, smooth plains of frozen lava. The far side is covered by them by only the smallest sliver, a tiny fraction, barely a trace. Where the near side has broad, pooling oceans of dark stone, the far side has almost none. It is, instead, almost entirely the bright, rough highland kind of land, pale and rugged, crowded with craters, scarred and pitted and busy from edge to edge. The dark seas that define the face we know are simply, almost entirely, absent from the face we do not. The far side is a different kind of place. It wears no calm grey seas. It is all bright, rugged highland all the way around. Take that in slowly, because it is the heart of the whole strangeness. Nearly a third of one face, drowned in dark, frozen seas. Almost none of the other. Not a little difference, an enormous one, visible from across 250,000 miles of space, plain in the very first blurred photographs, plainer still in every careful map we have made since. Picture the two of them together, as though you could hold the whole moon in your hands and turn it slowly. On the one side, the familiar face, soft and grey-eyed, its dark seas pooling in serene patterns, the gentle countenance we have always known. And, on the other side, turned away, a face that is bright and pale and endlessly cratered, rough as old bark, scarred from pole to pole, with hardly a single dark sea to soften it. The same small world, two utterly different faces. It is as though the moon were two moons fused into one, a calm, dark-eyed half and a bright, restless half joined together and spinning slowly through the dark, showing us only the gentle one, hiding the rugged one away. And remember, the far side is not hidden because it is somehow lesser or damaged or strange in a way that the moon is ashamed of. It is hidden simply by the geometry lock, by the accident of which face happened to settle toward the earth. It could just as easily have been the rugged face we saw every night and the gentle one hidden. There is no meaning in which side faces us. And yet, there is deep meaning in the fact that the two sides differ at all, because they should not so much, not like this. A small world formed all at once from the same material ought to be roughly the same all over. The asymmetry is the puzzle, and the seas are its most visible sign. There is a quiet tenderness in remembering that those dark seas, the ones the far side lacks, are the very marks that humanity has been reading and dreaming on for as long as there have been eyes to look up. Across the world, in countless cultures, people gazed at the same dark patches and saw gentle things in them. Some saw a face, the soft features of a person looking down. Some saw a rabbit, curled and quiet, its ears and body traced in the grey markings. Some saw a figure carrying a bundle, or a toad, or a woman at a loom. Every one of those images, in every one of those cultures, was drawn from the same dark seas of the near side, the only side anyone could see. The far side, with its missing seas, holds none of those figures. It has been a part of no one's lullaby, a character in no one's old story, because no one ever saw it. All the gentle imaginings of the moon, all the faces and rabbits and quiet figures of 1,000 traditions belong entirely to the half that faces us. The hidden half has been, until our own time, outside of every human dream of the moon, a face that no story ever found, simply because it never showed itself to be storied. Let us sit a little longer with the strangeness of those missing seas, because the contrast is so stark. On the near side, the lava found its way up and out, again and again, flooding basin after basin, laying down sheet after sheet of dark stone, building the great calm plains. On the far side, in the same world, born of the same fire, the lava mostly did not. The far side stayed bright and rough and dry of these floods, its low places never filled, its surface left as the cratered highland it had always been. Why should the molten rock have risen so freely on one side and so rarely on the other? Both sides have low basins where lava could have pooled. Both sides were struck by impacts that might have opened the way. And yet one side bled lava and the other held it in. Seas chose a side, and we do not, at first glance, understand why. It is worth pausing on the bright rough land too, the highlands, because they are the older and the more honest face of the moon, in a way. The pale, cratered highlands are the moon's original surface, the ancient crust that formed when the young moon first cooled and hardened long before any lava floods came later to drown parts of it. That surface has been sitting there, exposed, for billions of years, and across all that time it has been struck over and over by everything the solar system threw at it. Stones, boulders and mountains of rock falling out of the dark, each one digging a crater, the craters piling upon craters, until the whole highland surface is a crowded jumble of overlapping rings, old craters softened and broken by newer ones, a record of unimaginable ages of slow bombardment. To look at the bright highlands is to look at deep time itself, written in overlapping circles. The dark seas, by contrast, are younger. They are smooth precisely because the lava flooded over the old cratered ground and erased it, laying down a fresh dark surface that has had less time to gather new craters since. So when you look at the near side, you are seeing two ages at once, the ancient bright highlands and the younger dark seas pooled among them. Now here is the quiet wonder. The far side is nearly all that ancient bright highland, all that crowded old cratered land, almost untouched by the younger floods. The far side is, in a sense, more ancient on its surface, more purely the moon's original face, because so little new lava ever came to cover it over. It kept its old crowded countenance, while the near side had much of its old face smoothed away under the dark seas. So the two faces differ not only in colour and texture, but in a kind of age. The near side is partly resurfaced, partly made young again by lava. The far side is mostly old, mostly original, mostly the face the moon wore at the very beginning. Let us imagine standing on each side for a moment, gently, just to feel the difference in the body. On the near side, if you stood in the middle of one of the great dark seas, you would find yourself on a broad, smooth, dark plain, rolling away nearly flat to a close. Horizon, the ground a dark grey stone, the sky black, the earth hanging blue and still above you. It would feel almost calm, almost gentle, a wide, quiet plain under a black sky. But on the far side, if you stood in the bright highlands, you would be in a rougher and wilder country, a jumbled land of craters within craters, ridges and rims and hollows. In every direction, the ground pale and broken, the horizon crowded with the soft, worn shapes of ancient impacts, and above you, no earth at all, only the black sky and the slow sun and the unblinking stars. Two different worlds to stand upon, one smooth and dark and watched over by the earth, one rough and bright and utterly alone, and the brightness itself is part of the strangeness worth holding for a moment. The far side, being almost all highland, is on the whole a paler, brighter surface than the near side, which is darkened by its broad seas. If you could somehow swap the two, if the rugged bright face were turned toward us, and the dark sea-covered face hidden away, the moon in our sky would look noticeably different, brighter and more uniform, without the familiar dark markings that make the face we know. The man in the moon, the rabbit, the figures that peoples all over the world have seen in the lunar markings for thousands of years, all of them are drawn by the dark seas of the near side. Had the far side faced us instead, there would be no such figure, no face, only a bright and evenly cratered disk. The familiar face of the moon, the one woven into the myths and lullabies of every culture, exists only because the side with the seas is the side that happened to turn our way. The other side has no face to find. It is too evenly rough for the eye to make a figure of it. That difference between the side that flooded and the side that did not is the surface, sign of something deeper, something hidden beneath the rock. Because the seas did not simply decide on a whim which face to grace. The reason the lava rose on the near side and not on the far side has to do with what lies underneath, with the very thickness of the shell of rock that wraps each hemisphere. The asymmetry you can see, the asymmetry of the seas, is the visible top of an asymmetry that goes all the way down. And to understand the seas, we have to go beneath them, into the hidden shell, into the crust of the moon. It is worth saying gently how completely we now know both faces, because it makes the mystery sharper rather than softer. After those first blurred photographs, we did not stop looking. Spacecraft after spacecraft went to the moon, circling it, mapping it, photographing every part of both hemispheres in fine detail. We have now charted the far side as thoroughly as the near, every crater, every ridge, every pale plain, laid out in maps as detailed as any we have of the earth. We have measured the height of the land across the whole moon, traced the shape of every basin, weighed the pull of gravity over each region to sense the rock beneath. The far side is no longer a blur. It is one of the best mapped places off the Earth, and the more carefully we have mapped it, the clearer the asymmetry has become, and the harder it has been to explain away. This is not a trick of poor old photographs. It is a deep, real, well-measured fact about the moon. The two halves genuinely differ in their seas, in their surface, in the very land, and the better we look, the stranger it seems that one small world should be so unlike itself from one side to the other. And let us hold the scale of the difference honestly, because it is not subtle. We are not talking about a slightly different shade here, a few more craters there. We are talking about a near side where almost a third of the face is drowned in dark frozen seas, and a far side where those seas are all but absent, a mere trace. We are talking about a face that has been smoothed and resurfaced over wide regions, and a face that has kept its ancient rugged skin almost everywhere. If you saw the two hemispheres without being told they were the same world, you might well guess they were two different moons, formed in different places, with different histories, and yet they are one body, one birth, one history, and somehow two faces. That is the wonder that has kept scientists turning the problem over for decades, and that keeps it, even now, not fully solved. There is a gentle humility in that, and it is part of why this is such a lovely thing to rest with at night. Here is the moon, the nearest world to us, the one we have visited with our own feet, the one we have mapped from pole to pole on both its faces, the one that has hung in every human sky since the beginning. And still, with all of that, we cannot say for certain why it wears two different faces. The most familiar object in the heavens is still keeping a quiet secret. There is something comforting in that, I think. The universe has not run out of mysteries, and some of them are not far away at all. One of them is hanging right outside tonight, showing you its gentle face, holding its strange one turned away. But before we descend, simply rest for a moment in the wonder of the two faces. Let your mind hold them gently, the near and the far, the dark-eyed and the bright, side by side. Two countenances of one quiet world. It is one of the strangest facts about the most familiar object in our sky, that it is not the same all the way around, that it keeps a different face turned secretly away, and that we did not even know it until the day before, yesterday, in the long span of human time. And carry with you, as we go down, the one simple question that the two faces leave us holding. Why did the lava rise on the side we see, and not on the side we do not? Everything else, all the strangeness of the far side, gathers around that one quiet question. The seas chose a face. We want to know why. Breathe slowly. Let the two faces drift together in your mind, and let us go a little deeper, now beneath the seas, to find the reason they pooled on one side and not the other. So let us go beneath the surface, into the rock itself, because the first real clue to the mystery is hidden there, in something we cannot see by looking, only by measuring. The two faces of the moon are not only different on the outside, they are wrapped in shells of different thickness. Think of the moon for a moment as having a structure a little like the Earth. There is a deep interior, a core and a mantle of dense rock that was once hot and is now mostly cooled. And wrapping around that interior like a skin, like the shell of an egg, there is the crust, the outer layer of lighter rock that formed when the moon's surface cooled and hardened long ago. The crust is the part we walk on, the part we see, the bright highlands and the dark seas all sitting on top of it. And here is the deep clue. The crust is not the same thickness all the way around. On the near side, the shell of crust is thinner. On the far side, it is much thicker by a great deal, by something like 20 kilometers on average. A substantial difference in the depth of solid rock, wrapping each hemisphere. Let that settle, because it is the key that unlocks the seas. The far side is wrapped in a thicker shell of rock than the near side. And once you know that, the mystery of the missing seas begins gently to make sense. Remember what the dark seas are. They are floods of lava that welled up from deep inside the moon, from the hot mantle below the crust, and spread across the surface and froze. For that lava to reach the surface, it had to find its way up through the crust, through the shell of rock, from the molten depths below to the open surface above. The lava lived deep down. The surface is where we see it, and in between lay the crust, the bend, barrier, the shell it had to cross. Now picture the difference the thickness makes. On the near side, with its thinner shell, the lava had a shorter distance to travel, a thinner barrier to cross. When a great impact struck and cracked the crust, or when the pressure of the hot interior pushed upward, the molten rock could more easily find a path through the thinner near-side crust, breach it, and pour out onto the surface to pool in the low basins. The thin shell could be opened, the seas could form, but on the far side, with its much thicker shell, the lava faced a far greater barrier. The same impacts, the same upward pressure met a deeper, thicker wall of solid rock, and mostly the lava could not get through. The thick, far side crust held. It sealed the molten rock beneath it, kept it down, would not let it reach the surface to flood and pool. And so the far side stayed bright and bare, its low basins never filled, its surface never resurfaced by the dark floods, because the lava that might have flooded it could not cross the thicker shell. Feel how neatly that fits. The seas pooled on the near side because the near side crust was thin enough to let the lava through. The far side lacked seas because its crust was too thick for the lava to breach. The visible asymmetry, the dark seas on one face and the bright bareness of the other, is the surface expression of the hidden asymmetry, the thin shell on one side and the thick shell on the other. The seas chose the near side because the near side was the side the lava could reach. The whole strange difference in the two faces follows gently from this one deep fact about the thickness of the rock. It is worth holding the simple image of it for a moment, because it is so easy to picture. Think of two eggs, one with a thin shell and one with a thick shell, and imagine tapping each from the inside. The thin shell cracks and lets what is within seep out. The thick shell holds and keeps it sealed. The moon is like that, one hemisphere wrapped in a thin shell that the lava could break through, the other wrapped in a thick shell that held the lava in. The dark seas are the places where the shell was thin enough to let the inside out. The bright far side is the place where the shell was too thick, and the inside stayed in. That single picture, a thin shell and a thick shell on the two halves of one small world, holds nearly the whole surface mystery of the moon inside it. And how do we know the crust is thicker on the far side if we cannot cut the moon open to see? This is a lovely piece of quiet detective work, and it is worth understanding because it shows how we can sense the unseen. We measured the moon's gravity very precisely from spacecraft circling close above it. Here is the idea. Where there is more rock packed beneath a region, the pull of gravity there is very slightly stronger, and where there is less rock, slightly weaker. By flying spacecraft over the moon and watching with exquisite care how their motions sped up and slowed down by tiny amounts as they passed over different regions, scientists could map the pull of gravity across the whole moon, and from that work out how the rock was distributed beneath the surface, how thick the crust was here, how thin it was there. They sent a pair of spacecraft to do exactly this, flying one behind the other, measuring the minute changes in the distance between them as the gravity of the moon tugged each one, and from that delicate dance they read the hidden structure of the crust, and what they found confirmed it. The far side crust is substantially thicker than the near side crust. We weighed the shell of the moon from orbit without ever touching it, and felt asymmetry in the very pull of its rock. There is a beautiful detail in how that crust first formed, and it is worth knowing because it makes the thickness difference even stranger. When the moon was very young, just after it formed, it was not solid at all. Its outer regions were molten, a vast ocean of liquid rock, glowing, churning, covering the whole young moon in a sea of melted stone. We call it the magma ocean. And as that ocean of molten rock slowly cooled, something gentle and important happened. The lighter minerals that crystallized out of the melt were buoyant. They floated, like froth rising to the top of a cooling liquid. The light crystals drifted upward through the magma ocean and gathered at the surface, where they collected into a thickening raft of pale rock. That floating raft of light crystals, hardening at the top of the cooling magma ocean, became the moon's first crust, the bright highland rock that still covers so much of it today. The whole original surface of the moon is, in a sense, frozen froth, the light scum that rose to the top of a global sea of melted stone and set there. Now here is the strangeness. If the crust formed as a floating raft on a global magma ocean, you might expect it to gather evenly, the same thickness all the way around, the way froth settles evenly on a still cup. But it did not. The raft grew thicker on the far side and thinner on the near side. Something made the light crystals pile up more deeply on the hidden hemisphere than on the one that faces us. The crust did not set evenly, it set lopsided. And that lopsidedness is the deep root of everything, the thicker shell that held back the seas, the asymmetry written into the moon at its very making. So when we ask why the far side crust is thicker, we are really asking why the frozen froth of the magma ocean gathered more deeply on one side than the other. Billions of years ago, in the first cooling of the young moon, there is one more measured clue that points the same way, and it is a subtle and lovely one. The moon's center of mass, the balance point of all its rock, is not at its geometric center. It is shifted slightly toward the Earth, toward the near side, by a couple of kilometers. Think about what that means. If the far side is wrapped in a thicker shell of lighter crust, and the near side in a thinner shell, then more of the moon's heavier, deep rock sits a little closer to the near side surface, and the balance point of the whole moon is pulled gently toward us. The moon is very slightly lopsided in its very balance, leaning toward the Earth. And that lean is another fingerprint of the uneven shell. We can measure that offset precisely, and it agrees with everything else. The thicker far side crust, the thinner near side crust, the seas pooled on the near side, the center of mass, shifted toward us. All of it fits together into one consistent picture of a moon that is quietly asymmetric to its core. So now we have descended one layer into the mystery. The two faces differ because the two shells differ. The thin near side let the seas form. The thick far side held them back. But notice gently that we have not actually solved the puzzle. We have only moved it down a layer, made it deeper, because now the question is no longer why does the far side lack seas? The question is, why is the far side crust so much thicker in the first place? What could make one half of a small world wrap itself in a deep shell of rock while the other half stayed thin? The asymmetry of the seas was the surface sign of the asymmetry of the crust. And the asymmetry of the crust is the sign of something deeper still, something in the way the moon formed and cooled, some ancient difference between the two hemispheres written into the rock when the moon was young. We have found the shape of the mystery. We have not yet found its cause. Let us slow down and picture the making of a sea gently, because it helps to feel how the thickness matters. Imagine the early moon, its froth crust set, its interior still hot, still holding pockets and depths of molten rock. And imagine, out of the dark, a great stone falling, an asteroid or a fragment of a shattered world, striking the moon with terrible force. The impact gouges out an enormous basin, a vast bowl in the crust, throwing rock in every direction, leaving a great depression where it struck. That happened many times on both faces, in the moon's young and violent age. And then, slowly, over the long ages that followed, in some of those basins, the molten rock from below began to rise. Where the crust beneath the basin was thin enough, the lava found cracks and paths and welled up gently over millions of years, flooding the basin floor, layer upon layer, each flow cooling and the next rising over it, until the great bowl was filled with dark frozen lava, smooth and level. That is a sea. That is how a mare was made. A great wound, and then a slow healing flood of dark stone pooling in the hollow. Now you can feel why the thickness of the crust decided everything. On the near side, beneath the basins, the crust was thin and the lava could reach up and flood. So the near side basins filled one after another and became the dark seas. On the far side, beneath its basins, the crust was thick and the lava mostly could not reach the surface, no matter how deep the basin. So the far side basins stayed empty, unflooded, bright. Bowls in the bright highlands, never healed by the dark floods. The far side has great basins too, enormous ones, but they are mostly dry of lava, unfilled, because the thick shell kept the molten rock sealed below. It is the same story everywhere on the moon. Where the shell was thin, the seas came. Where the shell was thick, they did not. The thickness of the rock wrote the map of the seas, and the timescales here are gentle and vast, worth letting your mind drift across. The impacts that dug the great basins happened billions of years ago in the moon's distant youth. The lava floods that filled the near-side seas came later, but still mostly billions of years ago, when the moon was young enough inside to still bleed molten rock. And then, slowly, the moon cooled. Its interior fire faded. The floods stopped coming, and for a very long time, since billions of years, the moon has been quiet, its seas frozen, its surface still, gathering only the slow, patient rain of small impacts that gently pit and soften the land over the ages. The face you see tonight was mostly finished billions of years ago. You are looking at something almost unimaginably ancient, a face set in stone before there was complex life on Earth, held unchanged through all the ages. Since showing you tonight very nearly exactly what it showed the first creatures that ever crawled onto land, let us rest here a moment in the satisfaction of having understood one layer before we go looking for the next. There is something deeply pleasing about the thicker shell because it ties two strange facts together into one. The missing seas and the thicker crust are not two separate mysteries. They are one mystery seen twice. The far side lacks seas because the far side crust is thick. Solve the crust and you solve the seas along with it. This is how understanding often grows, not by answering a question outright, but by showing that two puzzles are really the same puzzle, and so reducing the number of things you have to explain. We began with two strange faces. We have found that the strangeness comes down in large part to a single difference, the thickness of the shell. One difference beneath everything, shaping the whole. There is a quiet lesson in how the mystery keeps moving deeper as we chase it, and it is worth sitting with for a breath. We began at the surface with two faces that simply look different, one dark-eyed and one bright. We asked why, and the answer led us down a layer to the seas, the floods of lava that darken one face and not the other. We asked why the seas pooled on one side, and the answer led us down another layer to the crust, the thin shell on the near side and the thick shell on the far. And now we ask why the crust is uneven, and the answer waits a layer deeper still in the making and cooling of the young moon. Each answer is real and satisfying, and each one opens onto a deeper question. This is the way of curiosity, and it is a gentle thing to rest in rather than to chase too hard. We do not have to reach the very bottom tonight. It is enough, and it is lovely, to descend slowly, one understood layer at a time, feeling the mystery deepen as we go, knowing that even the scientists who have given their lives to this have not yet touched the floor, and there is a comfort in that, the same comfort we found before. The moon is close. We have walked on it. We have mapped it utterly, weighed its rock from orbit, measured the lean of its very balance toward the earth. And still it keeps a secret in its depths, the secret of why it set itself lopsided in the first cooling of its froth crust. The nearest world to ours is still, in its quiet way, more than we have fully understood. We can hold that, not as frustration, but as a kind of gift, a reminder that wonder does not require great distance, that something genuinely unsolved is hanging right there in your window tonight, wearing its familiar face, keeping its strange one turned away. Let that sit gently as we prepare to go and see the greatest single feature the hidden face carries. But before we go searching for why the shell is uneven, there is one more feature of the far side we have to visit, the single most dramatic thing it carries, a scar so vast that it dwarfs every other feature on the moon, a wound from the deep past so enormous that it may itself be tangled up in the story of the thick crust and the missing seas. It sits near the bottom of the far side, near the South Pole, and it is one of the largest things of its kind in the entire solar system. Let us drift down to it now, gently, and stand at the edge of the greatest wound the moon has ever taken. Breathe slowly. Let your body settle a little deeper, and let us go and see the great basin in the south. Let us drift down now to the southern part of the far side, near the bottom of the hidden hemisphere, close to the moon's south pole, and stand at the edge of the single greatest feature the moon carries. It does not look like much at first, because it is too big to see. It is a crater so vast that you cannot take it in. It is called the South Pole-Aitken basin, and it is one of the largest impact scars in the entire solar system. Let us build a sense of its size slowly, because the numbers alone do not land. An ordinary crater on the moon, the kind you can see through a small telescope, might be a few kilometers or a few tens of kilometers across. A neat round bowl with a raised rim, the sort of thing made when a stone falls from space and gouges out a hollow. The South Pole-Aitken basin is not a few kilometers across. It is roughly 2,500 kilometers across. 2,500. It stretches across a huge fraction of the entire far side, from near the South Pole reaching up toward the equator, a bowl so wide that it would span much of a continent on Earth. If you stood at its center, its rim would be so far away, beyond the curve of the moon's horizon, that you could not see the far edge at all. You would have no sense of standing in a crater. You would simply be standing on a vast, slightly lower plane, with the land rising imperceptibly over hundreds of kilometers toward distant rims you could never glimpse. It is a crater you could stand inside and never know, because it is larger than your whole horizon. To put that width in gentle perspective, the whole moon is only about 3,500 kilometers across, and this single basin spans roughly 2,500 of them. So the great scar reaches across the better part of the entire width of the moon. It is not a feature on the moon so much as it is a feature that takes up much of one whole side of the moon. Imagine a wound on a body that spans most of its width. That is the scale we are speaking of. The South Pole-Aitken basin is not a crater the moon happens to have. It is very nearly a defining shape of the far side itself. And it is not only wide, it is deep. The floor of the basin lies many kilometers below the surrounding highlands, one of the lowest places on the entire moon, gouged down toward the moon's hidden interior. It is among the largest and deepest impact basins known anywhere in the solar system. A colossal bowl punched into the bottom of the far side, so enormous that for a long time before we mapped the moon carefully, it was hard even to recognize it as a single crater, because nothing in our experience prepares us for a crater that big. Let us sit gently with what made it. To dig a hole that wide and that deep, something struck the young moon with a violence almost beyond imagining. Some great body out of the early solar system, a mountain of rock perhaps hundreds of kilometers across, came down onto the far side and struck with a force that defies any comparison we have. It would have released more energy in an instant than we could ever picture, melting and shattering and flinging rock across the whole moon, throwing debris up and out, gouging a wound thousands of kilometers wide in a matter of moments. It happened very long ago, in the moon's young and violent age, when great impacts were far more common than they are now, when the solar system was still littered with the leftover rubble of its making, and worlds were still being hammered into their final shapes. The South Pole-Aitken Basin is a frozen record of one of those ancient catastrophes, perhaps the greatest blow the moon ever survived. And here is what makes it more than just a big hole, what makes it matter for our mystery. An impact that enormous did not just dent the surface, it punched down deep toward the inside of the moon, perhaps all the way through the crust in places, perhaps deep enough to throw up material from the mantle below, the deep rock that normally lies hidden beneath the shell. So the South Pole-Aitken Basin may be a window, a place where the violence of the impact tore open the moon and exposed at the surface material from far deeper than we can usually reach. If that is so, then the floor of that great basin holds, lying open to the sky, rock from the moon's hidden depths, the kind of rock we almost never get to see. That is part of why it is one of the most scientifically precious places on the entire moon. It is not just the greatest scar. It may be a doorway, blasted open billions of years ago, down toward the moon's deep interior. There is something quietly overwhelming in standing, in imagination, in that vast basin. All around you, a plain that is in truth the floor of an ancient wound so large you cannot see its edges. Beneath your feet, rock that may have been thrown up from deep inside, the moon by a blow that happened before the earth had oceans, before there was any life here at all. And above you, the black sky, the slow sun, the stars, and no earth at all because you are on the far side where the earth never rises. You would be standing in the largest scar on the nearest world, in a place no eye saw until our own time, in a silence and a stillness that has held unbroken for billions of years. The violence that made it was beyond imagining. And what remains of that violence now is the deepest quiet there is. The wound is utterly still. The catastrophe is over. Only the vast, gentle bowl remains, resting in the dark. It is worth saying how we even came to know this basin properly, because it is part of the wonder. From close up, as we said, it is too large to recognize. You cannot see a crater whose far rim lies beyond the horizon. It was only when we could measure the height of the land across the whole moon, mapping the elevation of every region from orbit, that the basin revealed itself. When scientists laid out a map of the far side colored by how high or low the land sits, the Great Basin suddenly appeared, unmistakable, an enormous low region near the southern pole, a vast oval depression that nothing but a colossal impact could have made. It had been there all along, beneath the spacecraft, beneath the crowded craters, but it took a map of the whole to see it. Some things are too big to notice until you step far enough back. The greatest scar on the moon was hidden, in a sense, by its own size, until we learned to see the moon whole. And it has another quiet signature, written in the chemistry of its floor. The rock within, the Great Basin, is subtly different from the surrounding highlands, richer in certain elements like iron, the sort of material you would expect if the impact had dug down into deeper, denser rock and spread it across the basin floor. We can sense this from orbit, reading the faint signatures of different minerals in the light and other emanations from the surface. So the basin is not only a shape in the land, it is a patch of different rock, a great oval region where the moon's chemistry changes, exactly as it should if a giant impact had reached down toward the interior and turned it out across the floor. Everything fits the picture of an ancient, enormous blow that punched deep. We have even been able, very recently, to begin pinning down its age, and the answer reaches back almost to the beginning. The great impact appears to have happened more than 4 billion years ago in the moon's earliest age, not long after the moon itself formed. It is one of the oldest large basins on the moon, perhaps the oldest of the truly giant ones, a wound from the very dawn of the moon's existence. To stand on its flaw, then, is to stand on a surface shaped in the first chapter of the moon's life, a scar that has been resting in the dark for nearly the whole age of the solar system, older than almost anything you could name, older than the oldest rocks easily found on the restless surface of the earth, which has long since erased its own most ancient scars through its weather and its shifting crust. The moon keeps its old wounds, the earth does not. And so the far side of the moon holds, in this great basin, a memory of the early solar system that our own world long ago lost. And there is a beautiful thread connecting this ancient wound to the present moment, to the very newest chapter of exploration, which we will reach by the end of our journey. Because when, in our own time, a spacecraft finally landed gently on the far side of the proud moon, the first ever to do so, it sat down inside a crater that sits within this very basin on the floor of the great southern scar. And when, a few years later, another spacecraft scooped up soil from the far side and carried it home, the first far side samples ever held in human hands, that soil too came from within this basin. The greatest wound on the moon, the most precious and ancient place on the hidden face, is exactly where we have chosen to go first. The deep past and the present have met there on the floor of the oldest scar. But that is a story for a little later. Let us stay, for now, in the vastness and the stillness of the basin itself. And the great basin may be tangled up with the very mystery we have been following, the mystery of the thick crust and the missing seas. Because a blow that enormous, striking one side of the moon, would have done more than dig a hole. It would have sent unimaginable heat and energy coursing through the moon, melting and reshaping rock far from the impact, perhaps redistributing material around the whole body, perhaps altering the thickness of the crust on one side, perhaps even helping to set the asymmetry between the two faces. Some of the gentle theories we will explore next wonder whether a great impact like this one, or others like it, might be part of why the two hemispheres differ so much. The South Pole-Aitken basin is not only the moon's greatest scar, it may be a clue, a piece of the puzzle of why the far side is the strange, thick-shelled, bright-faced place it is. The greatest wound and the deepest mystery may be connected. Let us hold both possibilities gently, because they pull in opposite directions and both are worth feeling. On one hand, perhaps the great impact helped cause the asymmetry, a blow that enormous, landing on one side, could have heated and reshaped the moon in ways that left the two faces different, the energy of it coursing through the body, melting and moving rock, thickening the crust here, thinning it there. On the other hand, perhaps the asymmetry came first, set by the uneven cooling of the magma ocean we spoke of, and the great impact merely landed upon an already lopsided moon, adding its scar to a face that was already strange. We do not yet know which came first, the lopsided crust or the great wound, the cause or the addition. It may even be that they are woven together in ways we have not untangled, the impact and the asymmetry feeding into each other across the moon's young history. The honest picture is a tangle of ancient events, all of them long over, their order and their connections still being slowly worked out from the clues that remain. And the clues that remain are precious precisely because the moon is so still on the Earth. An impact this old would have been utterly erased long ago. Our restless planet, with its shifting crust and its wind and its rain and its oceans, wipes its surface clean over the ages, recycling its rock, smoothing away even the greatest scars, so that the Earth keeps almost no record of its most ancient wounds. But the moon is quiet. It has no wind, no rain, no oceans, no shifting crust to swallow its past, and so it keeps everything. Every great scar, every ancient basin, every blow it ever took in its young and violent age is still there, softened only slowly by the gentle rain of smaller impacts, preserved across billions of years. The moon is a kind of memory, a still and faithful record of the early solar system, holding in its rock the story of an age the Earth has long forgotten. The Great Basin is one page of that memory, the largest and one of the oldest, lying open on the hidden face, waiting patiently for us to learn to read it. There is something quietly steadying in that thought as you lie there in the dark. The moon remembers. It has held its great wound, unchanged, through all the long ages, through the rise and fall of everything on Earth, through the whole story of life, patiently, keeping its ancient scar in the silence of the far side, asking nothing, simply holding what happened. And now, at last, in our own brief moment, we have begun to go and read it. There is a gentleness in being the ones who finally arrive to listen to so old and patient a memory, but we are not certain. That is the honest and gentle truth that runs through this whole story. We can see the basin clearly. We can measure its width and its depth. We can stand at its edge in our minds and feel its scale. But exactly what it did to the moon, exactly how it connects to the thick crust and the missing seas, exactly what role it played in making the two faces so different, we do not fully know. It is one of several great clues sitting there on the far side, waiting to be fully understood. And that uncertainty is not a failure. It is simply where the edge of our knowledge falls, right now, on the floor of the largest crater on the moon. One more gentle detail, because it lets you almost picture the moment of the blow. The Great Basin is not a perfect circle. It is stretched, an oval, longer in one direction than the other. And that shape carries a hint about how the impact happened. A stone falling straight down tends to make a round crater, but a stone coming in at a low angle, striking a glancing blow across the surface, tends to gouge a longer, stretched scar in the direction it was traveling. The elongated shape of the South Pole-Aitken basin suggests that the great body that made it did not fall straight down but came in at an angle, sweeping low across the southern far side, striking a glancing, racing blow that tore a long oval wound into the moon. You can almost see it if you let yourself, a mountain of rock streaking in low out of the black sky billions of years ago, and the moon taking the blow along its flank, the wound stretching out in the direction of the strike, and then silence, the rock settling, the heat fading, the long stillness beginning, the stillness that has held ever since, that holds even now as you lie there. The great oval scar resting quietly on the far side, exactly as that ancient glancing blow left it. It is worth letting that scene fade slowly, the way a memory fades, because it is the only kind of motion this place has known in billions of years. One moment of unimaginable violence, and then an eternity of quiet. That is the rhythm of the far side. Ancient catastrophe, long since cooled into the deepest peace. There is something almost soothing in it when you hold it gently, the way even the most violent things, given enough time, settle into stillness and rest. So let us carry the great basin with us, this colossal still bowl near the southern pole of the hidden face, as we turn at last to the deepest question of all. Why? Why is the far side wrapped in a thicker shell? Why did the seas pool only on the near side? Why does the moon wear two such different faces? We have gathered the clues, the missing seas, the thicker crust, the lopsided balance, the greatest wound. Now let us gather the gentle theories of how it all came to be, the quiet possibilities scientists hold, none of them certain, all of them beautiful. Breathe slowly. Let yourself settle a little deeper, and let us go looking softly for the why. Now we come to the heart of the mystery, the gentle question that has no settled answer. Why? Why did one half of the moon grow a thicker shell while the other stayed thin? Why does the moon wear two such different faces? There are several beautiful possibilities, and we are going to walk through them slowly, as quiet maybes rather than firm answers, because the honest truth is that no one yet knows for certain which, if any, is right. The first idea is the gentlest, and it begins with the earth. Cast your mind back to the very beginning, to the time just after the moon formed. The moon was born, most scientists believe, out of a colossal collision, when a body roughly the size of a small planet struck the young Earth and flung a great cloud of molten debris into orbit, and that debris gathered together and cooled into the moon. So the moon was born close to the Earth, much closer than it is now, and it was born hot, molten, glowing, and the Earth at that moment was also molten and glowing, a vast ball of incandescent rock, far hotter than it is today, blazing in the young moon's sky like a second sun. Now remember that the moon became tidally locked early, holding one face toward the Earth, and picture what that meant in those first ages. One side of the moon, the near side, faced the Earth. That great glowing ball of heat, always, never turning away. And the other side, the far side, faced out into the cold black emptiness of space, away from the Earth, into the deep chill of the void. So the two faces of the young molten moon were in very different conditions. The near side was bathed in the heat radiating from the blazing nearby Earth, kept warm, kept molten longer. The far side faced only the cold of space, and so it could cool faster, radiate its heat away into the dark, and begin to harden sooner. And here is the gentle idea. If the far side cooled first, it could begin to grow its crust, first gathering the light floating crystals into a hardening shell, while the near side was still kept molten by the Earth's heat. Over time, the far side, cooling steadily into the cold of space, could build up a thicker shell of crust, while the near side, warmed by the calm Earth, stayed thinner and more molten for longer. The asymmetry of heat, the hot Earth on one side and the cold space on the other, could become an asymmetry of cooling, and so an asymmetry of crust. The far side grew thick because it faced the cold. The near side stayed thin because it faced the fire of the young Earth. It is a lovely idea, simple and gentle, and it may well be part of the truth. The second idea is more dramatic, and it has a strange beauty all its own. It is sometimes called the two-moon hypothesis. The thought is this: when the moon formed out of that great cloud of debris around the young Earth, perhaps it did not form alone. Perhaps the debris gathered into not one moon but two, a large one and a smaller, companion, both circling the young Earth together. The two moons would have orbited for a time, sharing the sky, a large moon and its little sibling. But such an arrangement may not have been stable forever. And so, the idea goes, eventually the smaller moon drifted toward the larger one, and they met, not in a violent high-speed crash, but in a slow, gentle collision. The little moon settling down onto the surface of the big one and spreading itself across one side. Picture that, softly, not an explosion, but a slow merging, the smaller moon drifting in at a low speed would not have blasted a crater. It would have splattered gently across one hemisphere, piling its rock up onto that side, spreading a great extra layer of crust across one face of the larger moon, and that face, the one that received the smaller moon, would end up wrapped in a thicker shell built up from the rock of its lost sibling. In this picture, the thick far side crust is the smaller moon itself, flattened and spread across the far side in a slow ancient merging, an extra layer of rock that is, in a sense, the body of a second moon that no longer exists. The far side is thick because another moon lies spread across it. It is a strange and haunting thought that the hidden face of our moon might be wearing the remains of a vanished companion, a sibling world pressed gently into its surface long ago. There is a third idea related to the great basin we just visited, and it brings the south, Pole-Aitken impact into the story. Perhaps the asymmetry was shaped, at least in part, by a colossal impact, the very kind that dug the Great Southern Basin, or others like it. A blow that enormous would have sent heat and energy surging through the young moon, melting and moving rock, and it might have redistributed material in a way that thickened the crust on one side and thinned it on the other, or stirred the moon's interior so that the lava later rose more easily on one face than the other. In this picture, the two faces differ because of an ancient impact, a single great blow that left the moon lopsided, its crust uneven, its seas destined to pool only on the side the impact left thin. The great wound and the two faces would be parts of one story. There is a fourth idea, quieter than the others, but in some ways the most telling, and it has to do with where the moon keeps its warmth. When the magma ocean cooled and the crust formed, the very last part of the melt to harden was rich in a peculiar mixture of elements, including the elements that give off heat as they slowly decay, the natural warmth makers buried in rock. And on the moon, that special heat-rich material is not spread evenly. It is concentrated, strangely, almost entirely on the near side, gathered in and around the great dark seas. The near side holds the moon's hidden hearth, the warm, rich rock, while the far side is comparatively depleted of it, cooler, plainer, more barren in those heat-making elements. Think about what that would do. The near side, holding the warm, rich material, would have stayed hotter for longer, its interior kept gently simmering by the slow heat of those buried elements, its rock more easily melted, its lava more able to rise and flood the stone basins. The far side, lacking that warm, rich material, would have cooled and stiffened and stayed quiet, its lava sealed below, its basins left dry. So the asymmetry of the seas might trace back to an asymmetry of warmth, the near side keeping the moon's heat, rich rock and so staying volcanically alive, the far side going cold and still. But this only deepens the puzzle in the loveliest way, because now we must ask why the heat-rich material gathered on the near side in the first place. Why did the moon tuck its warm hearth into the side that faces us and leave the hidden side cold? We are back again to the same root question, the same ancient lopsidedness seen now in the distribution of warmth rather than the thickness of crust. Every clue followed far enough leads back to that single early asymmetry, set somehow in the moon's first making, whose true cause we still chase. It is worth noticing how these ideas are not really rivals so much as different doorways into the same room. The cold of space cooling the far side, the lost second moon spread across it, the great impact reshaping the young body, the heat-rich rock gathered on the near side. All of them are trying to explain the same single fact, that the moon set itself lopsided long ago. They might even work together. Perhaps the near side faced the hot earth and stayed warm, and the heat-rich rock gathered there, and a great impact added its mark, and all of it together tilted the moon into the two-faced world we see. Nature is rarely tidy. The true story may not be one clean cause, but a braid of several, woven in the moon's first 100 million years, when everything was hot and molten and still settling into the form it would hold forever after. We are trying to read that braid now, strand by strand, and we have not yet fully untangled it. And there are other gentle variations, other careful ideas, scientists adjusting and combining these pictures, wondering whether the asymmetry came from the cooling, or the merging, or the impact, or some blend of all of them, or something else not yet imagined. There are ideas about how the moon's interior may have churned unevenly, concentrating certain heat-producing elements on the near side, keeping it warm and active and prone to lava floods, while the far side stayed quiet. Each idea explains some of the clues. Each one leaves others unexplained, and none has yet won the day. Let us linger a little on the lost moon idea, because it is the one that most captures the imagination, and it is worth feeling fully. Imagine the young Earth freshly struck, its great cloud of molten debris settling into orbit. And imagine that cloud gathering not into one body, but into two, a large moon and a smaller one, perhaps a few hundred kilometers across, sharing the same orbit, circling the Earth together in a delicate balance. For tens of millions of years, they might have coexisted, two moons in the sky of the young Earth, the great one and its little companion, drifting in their shared dance. And then the balance failed, slowly, gently, as such balances do, and the smaller moon began to drift toward the larger. The approach would have been slow by cosmic standards, the little moon closing in over a long time, until at last it touched. And because the speed was low, it did not shatter or explode. It simply came to rest against the larger moon and spread, its rock flowing and piling across one hemisphere, pancaking onto the far side, adding its whole body as a thick new layer of crust. In a few hours, perhaps, the smaller moon ceased to be a moon and became, instead, the thick shell of the far side of the one moon that remained. If this is what happened, then every time you look up at the moon, the hidden face turned away from you is wearing, spread across it, the flattened body of a sibling world that vanished into it 4 billion years ago. It is one of the most quietly haunting ideas in all of planetary science, a second moon that did not so much die as merge, becoming forever a part of the one we know. There is a cousin of this idea that some scientists prefer, in which the body that struck was not a gentle second moon, but a wayward, wandering object, a small world or large asteroid from elsewhere in the early solar system that came down onto one side of the moon and added its material to that hemisphere. The spirit is similar, an extra helping of rock delivered to one face, thickening its crust, leaving the moon lopsided. Whether it was a slow merging sibling or a faster wandering stranger, the heart of the idea is the same. One side of the moon received an extra layer of rock that the other did not, and that is why one shell is thick and one is thin. The moon in these pictures is not lopsided because of how it cooled, but because of what landed on it, an addition from outside, pressed into one face in the deep past. Notice how different these ideas feel, even as they explain the same fact. The cooling idea is gentle and internal, the moon quietly thickening its far shell against the cold of space. No drama, only the slow work of heat draining away. The merging idea is external and a little mournful, a lost companion pressed into the hidden face. The impact ideas are violent and sudden, great blows reshaping the young world. And the heat-rich rock idea is subtle and chemical. The warmth gathered quietly on one side. Nature could have used any of them, or several at once. And the clues we have, the seas, the crust, the balance, the basin, the gathered warmth, do not yet point clearly enough to a single one. They are consistent with more than one story. That is exactly why the mystery remains open. This is the honest heart of it, and I want to share it gently because there is no disappointment in it, only wonder. We do not know which of these is true. We do not know why the moon wears two different faces. It might be the cold of space that thickened the far side. It might be a lost second moon spread across it. It might be a great ancient impact. It might be the uneven churning of the moon's hidden interior. It might be some combination we have not yet untangled, or some cause no one has yet thought of. The clues are real. The seas and the crust and the balance and the basin, all carefully measured, all genuine. But the story that ties them together, the single true account of how the two faces came to be, is still being written. The moon is keeping that part of its secret still. Hold that lightly and let it be a comfort rather than a frustration. We have come so far in understanding the moon. We know what the seas are and why they pulled where they did. We know the crust is uneven, and we have weighed it from orbit and felt the moon's own balance lean toward us. We know the great wound in the south and roughly how old it is. We have gathered the clues with patience and care. The only thing left unsettled is the very first cause, the deepest root, the reason the young moon set itself lopsided in the first place. And that is a wonderful kind of thing to have left unsettled, because it is the deepest and most interesting part, the origin, the beginning of the whole story. And there is something lovely in sitting with that rather than rushing past it. We so often want the tidy answer, the solved mystery, the case closed. But here is one of the nearest and most familiar objects in all the heavens, the moon that has lit every night of human history, and it still holds a genuine, open, unsolved question about its own two faces. The scientists who study it are not embarrassed by this. They are delighted by it, because an open question is an invitation, a reason to keep looking, to send new spacecraft, to gather new clues, to think new thoughts. The mystery of the two faces is not a gap in our knowledge to be ashamed of. It is a living question, still breathing, still waiting, hanging in the sky outside your window tonight. And the beautiful thing is that this is a mystery we can still work on, still push against, still hope to solve. It is not a question lost to the deep past with no evidence remaining. The evidence is right there, on the moon, in the rock of the far side, waiting. If we could gather enough of that far side rock, study it closely, read its age and its chemistry, its history, we might finally be able to tell the stories apart, to see whether the far side crust holds the fingerprint of a merged sibling moon, or the mark of uneven cooling, or the signature of a great impact. The answer is not hidden forever. It is hidden only until we go and look closely enough. And that is exactly what has begun to happen in our own time in the last handful of years. For the whole of human history, we could only see the far side from a distance, first not at all, then in blurred photographs, then in careful maps from orbit. But now, at last, we have started to go down and touch it, to land upon the hidden face, and even to scoop up its soil and carry it home. The tools to read the moon's oldest secret are finally, gently, being brought to bear. The mystery is still open, but it is open in the way a door is open, with someone at last stepping through. So let us hold all the gentle possibilities together, the cold of space and the lost moon, and the great impact and the churning depths, none of them certain, all of them beautiful. And let us turn, at last, to the newest chapter of all, the one being written in our own time, as small brave machines finally descend to the hidden face and begin, for the first time ever, to touch it and to bring a little of it home. Breathe slowly, let yourself settle, and let us go and visit the far side, not in imagination now, but as we truly have in these last few years, for the very first time. And so we come, at last, to the newest part of the story, the part that is happening now, in our own brief moment, after all the long ages of wondering. For the whole of human history, the far side was only something to imagine. Then, within living memory, it became something to photograph from a distance, and then to map carefully from orbit. But to actually go there, to land gently on the hidden face and touch it, that did not happen until just a few years ago, and it is a quietly beautiful thing that we have lived to see it. Landing on the far side is harder than it sounds, and the reason is gentle and a little surprising. When a spacecraft is on the near side of the moon, it can speak directly to the Earth, sending its signals straight home, because the Earth is right there in its sky. But on the far side, the Earth never rises. The whole bulk of the moon sits between a far sidelander and the Earth, blocking every signal. A spacecraft on the far side cannot call home directly, because there is a whole world in the way. So for a long time, even once, we could reach the moon, the far side remained out of reach for landing, not because we could not get there, but because once there, we could not hear it or speak to it. The answer was patient and clever. Before sending a lander to the far side, you first send a smaller spacecraft out beyond the moon to a quiet point in space from which it can see both the far side and the Earth at once, and have it hover there as a relay, a messenger, catching the lander's signals and passing them along to Earth and back. With that quiet relay in place, hanging in space beyond the moon, listening a lander on, the far side could finally have a voice. Its words would travel up to the relay, and from the relay home to Earth, and so the hidden face could speak to us at last, by way of a patient messenger placed carefully in the dark. And so, a few years ago, a spacecraft sent by China named Chang'e, after an ancient goddess of the moon, descended softly toward the far side, toward the floor of a crater that lies within the great South Pole-Aitken basin, the very basin we stood in earlier. It came down gently, slowing, settling, and touched the hidden face of the moon, the first spacecraft in all of history ever to land softly on the side we never see. Let that land for a moment. After all the ages of human beings looking up at the moon and never seeing, its other half, a small machine of our making, reached out across the dark and set itself down, intact and working, on the hidden face, and looked around and sent back, by way of the patient relay, the first pictures ever taken from the surface of the far side of the moon. Not from orbit, from the ground, from standing upon it. A little rover rolled out and began to trundle across the soil of the far side, leaving the first tracks ever pressed into that hidden ground. And then, a few years later, something even more remarkable. Another of these Chang'e spacecraft went to the far side, not only to land, but to gather. It descended to the floor of the Great Basin, scooped up the soil and rock of the far side, sealed it carefully away, lifted off again from the hidden face, and carried that precious cargo all the way home to the Earth. For the first time in history, human beings held in their hands a piece of the far side of the moon, soil that had lain on the hidden face for billions of years, never before touched, never before seen up close, carried gently across space and set down on a laboratory bench on Earth, where careful hands and patient instruments could finally read what it had to say. And what did it say? It deepened the mystery in the loveliest way, even as it answered small parts of it. The far side soil told us that volcanoes were active on the far side too, long ago, and that this volcanism lingered in places for far longer than anyone had expected across an immense stretch of the moon's history. It told us, through its chemistry, that the deep interior beneath the far side seems to be strangely drier than the near side, holding less water locked in its rock, another quiet asymmetry between the two halves to add to all the others. The far side is not only different on its surface and in its crust, it seems to be different all the way down in the very water content of its hidden depths. Each answer the samples gave came wrapped in a new question. The far side, touched at last, turned out to be even stranger and even richer than we had guessed. Its differences from the near side reaching deeper than the crust, down into the wet and dry of its inner rock. Let us sit a little longer with what the soil whispered, because each thing it said is quietly remarkable. It told us, first, that the far side had its own volcanic past, that lava did rise there too, at least in places, long ago, even if it rarely reached the surface to flood the basins, as it did on the near side. And it told us that this volcanic activity stretched across an astonishing span of time, that the far side was geologically alive in its quiet way for far longer than anyone had thought, with eruptions separated by well over 1 billion years. The moon, which we often imagine as a dead and changeless world, was warm and active within for ages, and the far side soil carries the record of that long, slow, inner life. It told us too something about the moon's ancient magnetism. The moon today has no global magnetic field to speak of, but long ago it did, generated by motions deep in its molten interior, and the far side samples held faint magnetic memories locked in their rock, showing that the moon's old magnetic field did not simply fade away steadily, but rose and fell, fluctuating, perhaps flickering back to strength at times before finally dying. Another small window into the moon's hidden inner history read from grains of far side soil, and it told us, most tellingly for our mystery, of that strange dryness. The rock of the far side interior, as best the samples reveal, holds less water than the near side, a deep asymmetry in the very wetness of the two hemispheres. This is a profound clue, because water in rock affects how easily it melts and flows, how volcanism behaves, how a world cools and lives. A drier far side and a wetter near side is yet another way the two halves differ, reaching down beneath the crust into the chemistry of the depths. And like every other clue, it deepens the question even as it sharpens it. Why should one half of the moon be drier within than the other? We add it to the list of asymmetries: the seas, the crust, the balance, the basin, the gathered warmth, and now the water, all of them pointing to a moon divided in two from its surface to its core, and all of them still circling that one unanswered question of why. So the mystery is not solved, even now, even with far side soil in our hands, but it is being worked on gently, patiently, with real pieces of the hidden face finally available to study. And that is a wonderful place for our story to rest, not at a tidy ending, but at a living edge, where new clues are still being read, where the oldest secret of the nearest world is slowly giving itself up to careful and patient people. The far side has kept its strangeness for billions of years. We have only just begun truly to listen to it, and there is no hurry. It will keep, as it always has, turning its hidden face quietly away, holding its secret, while we learn, a little at a time, to understand. Let us linger a little on those small machines, because there is real tenderness in what they did, and it is a gentle thing to carry towards sleep. The relay spacecraft, the patient messenger placed out beyond the moon, was given a lovely name drawn from an old story, a name that means something like the Bridge of Magpies, from a gentle legend in which birds gather to form a bridge across the sky so that two separated lovers can meet for a single night. It is a beautiful name for what the little relay does, forming a bridge across the dark, so that the hidden face and the distant earth can speak to one another across a gap that nothing could otherwise cross. There is poetry in that, in naming a cold machine in deep space after a bridge of birds built for a reunion. The far side and the earth, long separated, given a bridge at last. And picture the little rover trundling slowly across the floor of the great basin on the hidden face, in a silence deeper than any silence on earth. It moved gently, carefully, a small wheeled thing on an ancient and enormous scar, pausing to study the soil, to look at the rocks, to sense the rock thrown up from the moon's depths by that old impact. It had to rest through the long far side nights, 2 weeks of darkness and brutal cold at a time, powering down into a kind of sleep, waiting for the slow dawn to return and warm it back to waking. Through many of those long cold nights, it slept and woke and slept. Again, patient as the place it explored, gathering its small, careful observations season by season on the hidden face. There is something quietly moving in that image, a little machine resting through the 2-week nights of the far side, waking to the slow sunrise, going about its gentle work in a place no eye had ever seen from the ground, all alone, on the hidden hemisphere, speaking home only by way of the bridge of magpies, hanging in the dark, and then the gathering, the sample return, which is harder still and even more wonderful, to go down to the far side, scoop up its soil, and then lift off again from the hidden face and fly all the way home is one of the most difficult things anyone has ever done in space. Every step had to work perfectly. The descent, the gathering, the sealing, away of the precious soil, the launch back up from the far side, the long journey home, the careful fall through the Earth's air, the gentle landing. And it worked. A small capsule came down at last onto the Earth, carrying within it something that had never been on Earth before in all of history, a piece of the far side of the moon. Think of the people who opened that capsule, who first held that soil, knowing that no human hand had ever touched material from the hidden face before. After all the ages of wondering what was over there, someone finally held a piece of it, cool and grey and ancient, in a laboratory on Earth. The hidden half brought home. It is the kind of thing that, if you let yourself feel it, is genuinely wondrous, a quiet triumph of patience and care, the gathering of a secret that had been kept since before the Earth had life. Let us also sit gently with what it means that the place they chose to go was the great basin, the oldest wound. They did not land just anywhere on the far side. They went to the floor of that ancient scar, to the one place where the impact may have torn open a window toward the moon's depths, where the soil might hold rock from far down inside. So the samples carried home are not only the first from the far side, they may be among the deepest, the most ancient, the most telling pieces of the moon we have ever held. Soil shaped by the greatest blow the moon ever took in its earliest days. The deep past and the present reached out and touched across billions of years on the floor of the oldest scar when a small machine of our making set down there and gathered up a handful of that ancient ground. It is a meeting across almost the whole age of the solar system. An old wound and a young, curious species finally come together in the quiet of the far side, and it is worth remembering that this is only the beginning. More spacecraft will go to the far side in the years to come, from more than one nation, to land and to look and perhaps to gather again. The hidden face, sealed away from us for the whole of human history, is becoming, in our own time, a place we visit, a place we study from the ground, a place whose soil sits in our laboratories. The mystery of the two faces may yet be solved, not in our imaginations, but with real far side rock in careful hands. Read closely enough to tell at last which of the gentle stories is true. We are living in the first years of truly knowing the hidden half of the moon. After all the ages of wondering, the answers are finally beginning to come home. Let us gather the whole journey now, softly, and let it carry us down toward rest. We began with the most familiar sight in the sky, the patient face of the moon, the same face shown to every human who ever lived. We found that it keeps another face turned, forever away, hidden until almost our own time. We saw how different that hidden face is, bright and rugged, and nearly without the dark seas that mark the side we know. We went beneath the surface and found the thicker shell, the deeper crust that held the seas at bay. We stood in the great wound near the southern pole, the vast ancient basin, one of the largest scars in the solar system. We gathered the gentle theories of why, the cold of space, the lost second moon, the great impact, the gathered warmth, none of them certain. And we came at last to the present, to the small brave machines that have finally touched the hidden face and carried a little of it home. There is a gentle thread that ties the whole journey together if you want one to hold as you drift off. It is the slow turning of the hidden into the known. For all of human history, the far side was pure mystery, unseen, unreachable, a blank. Then came the first blurred photographs, and the mystery gained a face. Then the careful maps, and it gained detail, the seas and the basin and the shape of the land. Then the measurements from orbit, and it gained depth, the thickness of its shell, the lean of its balance. And now, in our own years, the landings and the gathered soil, and it gains substance, real rock in real hands. Step by step, generation by generation, the hidden has been turning into the known, the blank slowly filling in, the secret slowly told. And yet, beautifully, the deepest question, the why, remains. We have learned almost everything about the far side except the one thing we most want to know, and even that is now within reach, waiting in the soil we have carried home. It is a lovely shape for a mystery to have mostly understood, still holding its deepest secret, and that secret at last beginning to yield. And through all of it, the moon has simply hung there in the sky, as it hangs there now, showing you its gentle familiar face, holding its strange one turned away. It does not know it is a mystery. It does not know we have wondered about it for all of human history, or that we have finally begun to visit its hidden half. It simply turns, slowly, in its ancient patient dance, one face toward us, one face toward the dark, as it has for billions of years and will for billions more. So let the far side drift now to the edge of your mind, that hidden hemisphere, bright, scarred and quiet, turned away from every window on earth, resting in the dark beyond the moon. There is nothing there that asks anything of you. There is only a still and ancient place. keeping its old secret gently, while you lie here, warm and safe, beneath the same moon that has watched over every night there has ever been. Let your breathing slow, let your body grow heavy. The moon is keeping its secret. You do not have to keep anything tonight. Let the hidden face turn quietly away. Rest now. Sleep well. Good night.